It's another Wednesday, so it's time for Wednesdays with Wendy, and I have a special helper here today. He's going to help me with our really cool science experiment. So we're going to be covering a lot of different topics today. One of them, we're talking again about the layers of the earth. Do you remember the layers of the earth that we talked about a few weeks ago? We talked about the crust, the mantle, and the core. But there's actually different ways that you can separate out the layers of the earth. You can do it by composition, or what they're made of, or by the way they behave, the mechanical layers. Today we're going to be talking about the mechanical layers. So the crust is actually broken into different parts. The lithosphere and the asthenosphere are two things that behave the same. They're both brittle. So the lithosphere is the very top part, the crust that we think about, and also the very top part of the mantle that behaves brittly. Brittle means this, it breaks. The asthenosphere, you want to do that part? Hold on, you want to break? Oh boy, that's going to be a mess. It's okay. Then the asthenosphere is right underneath of that, and that's another part of the top of the mantle, and that behaves more ductily. That means that things flow. So if we leave this on the counter for just a minute, we can watch that it'll flow out over time. That's important because that tells us how different things are going to work inside the earth, right? So in order for there to be an earthquake, you have to have brittle deformation. Things have to be able to break, but things also flow. We're also today going to be talking about glaciers. Now there's all different kinds of glaciers, and basically glaciers are made of snow and ice. Is snow heavy? Well, if you think about a snowflake, that's super light. What do you think about when you think about a snowflake? Is it light or heavy?
Light, but a giant snowflake this big is very heavy.
That's right. Like when we make a snowball, that gets heavier. Yeah, throw it and ouch. What happens if you have a whole mile of snow? Is that heavy or is that light?
Light.
Well, it would be heavy, right? What do you think would happen to the earth underneath all that weight of snow and ice? What do you guys think?
It would crack.
It might crack. It would maybe even go down. So here, let's draw. Can you draw some dots across here like this?
Yeah.
These are going to be like GPS stations. Put one right there. GPS means Global Positioning System. And you guys all know about GPS, right? We have them in our phones. Yeah, put a couple more. We have them in our cars to tell us where we're going. And those are good, for some distance. It gives you a circle telling you where you are. When you have GPS instruments that are used for science, they are very, very accurate. They can tell you where that GPS monitor, that station is, within tiny, tiny, tiny measurements. So if things are changing on the surface of the earth, we can measure those changes in 3 dimensions. Thank you, that's perfect. By using GPS. Now we're going to pretend that all of these are different GPS stations, and we're going to set this, on top of what's called flubber. It's like slime. It's a non-Newtonian fluid, which means it doesn't behave like a solid or a liquid, really. And it depends on its state of stress as to whether or not it will break or flow. So what we're modeling here is actually the lithosphere and the asthenosphere. In this case, the lithosphere is the plastic part, and the asthenosphere is the part underneath. Now, Rowie, what does this feel like?
Squishy and slime.
And is it hard or soft? Or maybe a little of both?
Hard and soft.
Okay, we're going to put this is going to be like a glacier, okay? We're going to put this in this bowl. See, it's right on top of that GPS station right there. And we're going to see what happens. So there's lots of different kinds of glaciers. There's mountain glaciers that form on the top of mountains. There's valley glaciers that are in the valleys. There's Piedmont glaciers that are in sort of low-lying areas. Let's not mess with it. Let's let it do its thing. There's also ice caps and ice sheets. So do you know that most of Canada and part of the U.S. was once covered by a giant ice sheet? And we have evidence of that. How do we know there was a giant ice sheet there a long, long time ago if we can't see it? There were no pictures. How would we know? We have to be creative scientists, don't we?
We would have to walk there.
Yes, walking and making observations is a critical part of science. But We can also use our powers of observation to see things on the landscape called the geomorphology. We can see drumlins or little hills that were made by the ice. The Great Lakes, they were scooped out by this giant ice sheet. The other thing we can tell is that the ground is moving a certain way now. But why would that be? And then we can get really creative, and that's what this is. So if we look carefully at this, remember there was a GPS station underneath here? Which way was that moving? The one underneath. Up or down?
Down.
Yeah, it's moving down, right? It's getting pushed down by the weight of that glacier. All of these other GPS stations around it, do you see those? Can you see these dots?
Yeah.
Are they moving too a little bit? Yeah, some of them are tilting. So some are moving down and some are moving away, some are moving towards. So what do you think it's going to look like, Ro, if I pull this off? What are we going to see? Hi, Mr. Cat. We're going to pull this off now, so let's zoom in. Hold on, pull that piece off. What did it make?
A bubble.
It made a little hole. No, wait, look. Do you see the hole?
Yeah.
It was flat before, and now there's a dent. And that's one way we know that there were glaciers in a place. It pushed the ground down, but what's going to happen next? What do you think is going to happen? This dot in the middle, do you think that's moving up or down now?
Even down.
Well, could be.
Up.
Yeah, it's moving up because this got pushed down, but now that the ice went away, we just moved it. But in other normal life, ice goes away because it melts, right? So when these ice sheets melted, now the ground is going to rebound. This is called isostatic rebound. And so we can tell, even still in parts of Canada and the northern United States, GPS stations are moving up because they're recording the ground slowly moving back after the ice and snow of those ice sheets have been removed. Does that make sense? Now we have two different bowls here because this one is not very stiff. It has a different viscosity.
Whoa, it's light.
Yeah, and this one's harder, isn't it? It's a different viscosity. Viscosity is how well something flows. You can think about, it's about how thick something is. Okay, stick it in there and let's see. No, don't push. We just have to let it do its thing under gravity. You can mess with this one. Viscosity is how well something flows, how thick it is. You can think about it like toothpaste or water, right? Toothpaste has a very different flow than water. Water's runny. Yeah, ooh, don't eat that. Wouldn't taste good.
I know.
So basically these have different viscosities, and you can play with this at home if you have slime or the things to make flubber. All you need is some borax and some glue and water. Make sure your parents help you. And you can test out different viscosities, things that are very viscous and things that are not very viscous. So this is much more viscous. It was harder. And so it's going to take a little bit longer for this glacier to push it down. Why does this matter? Well, by looking at the rate of rebound of the Earth, we can figure out properties of the Earth that we can't see, like the viscosity of the asthenosphere, which is way far down below our feet. But all of this information helps scientists to know what happened in the past and how our world works.
Doesn't this look like a little one of the germs that no one sees, and they're very tiny and they don't do that stuff that bad?
Yeah, germs are very tiny, microscopic, that's right. That's a little tiny piece of something, which means it's also small. All right, that's all we have for today. If you want to practice this and need the recipe, I will post that in the comments. I'll also give you additional information about how we use... Hold on.
It's glue, borax, and water.
That's right. I'll give you additional information about isostatic rebound and about how we can use GPS to monitor the surface of the Earth. You can get great information and great hands-on activities from UNAVCO, UNAVCO. I'll post that link as well. Thank you. Be safe and happy Wednesday. Say bye.
Bye.